Okay, welcome back. Today we're going to talk about properties of equality. Now, properties of equality is actually a funny lesson because it usually comes around this time after you've been solving equations for a little while, and you've actually been using these properties quite significantly when you solve equations, but you haven't really given them names. All right, so let's go ahead and give them some names here. So the addition, subtraction, and multiplication and division properties, they're all of the same type. It says, these properties have an if-then statement. If A is equal to B, right? So if initially you have two things equal to each other, then A plus C must be equal to B plus C. Okay, so for instance, if 4 is equal to 8 over 2, then it's true that 4 plus 3 is going to be the same as 8 over 2 plus 3, right? Because you started out with two things being equal, and it says if I add something to both sides, they're still going to remain equal, okay? So this is like if you make the change of adding something to both sides remain equal. This is the same as the subtraction property. If A is equal to B initially, then subtracting C from both sides is going to remain, both sides are going to remain equal. Likewise with multiplication and division. So if you have A is equal to B, then A times C is equal to B times C, or A divided by C is the same as C divided by B divided by C, with the caveat that C can't be equal to 0. So with the exception that C can't be 0, because you can't divide by 0. Okay, the substitution property says that if A is equal to B, so if we've already established that these two things are equal to each other, then B can be substituted in for A in any equation. Okay, so I could set up a weird logical statement that says that like X is equal to Y. Okay, X is equal to Y. Let's say I have a statement here. These are equal to 12. Well, that would mean that 3Y plus 4 is equal to 12 as well. Because, so let's say I had an original equation here, and if I had X is equal to Y, well then anytime I see X in the equation, I can substitute in Y. All right. This often happens when you're asked to evaluate an equation where you say, okay, let's say evaluate this expression, rather, when you're asked to evaluate an expression, they say evaluate the expression for X is equal to 2. Well, these two things are equal to each other. That means that 2 can be substituted in for X anywhere you see it inside the expression. That's called the substitution property. In an earlier lesson, I accidentally switched around the symmetric and reflexive property. So be careful of that. The symmetric property says that if A is equal to B, then B is equal to A. Simply switching them around the equal sign. I remember the symmetric property by thinking about it as the symmetry of, symmetric means that what happens on one side is the same as the other side. So think about it as like a mirror. So if A is equal to B, then B is equal to A. You can switch them around the equal sign, okay? The reflexive property just says that A is equal to A. The transitive property, the reflexive property is sort of a very subtle statement, and you don't use it that often. The transitive property says that if A is equal to B, and B is equal to some other number C, then A must be equal to that third number C, right? So just go through that one more time. If A is equal to, if a first number is equal to a second number, and a second number is equal to a third number, then the first and third numbers are equivalent to each other. Okay. Now, what you might be asked to do is to look at, so the left-hand side here is statements, and on the right-hand side, we're going to fill it in with a column, in this right-hand column here, by identifying the property that was used to solve the equation below. So we started out with two expressions equivalent to each other, and we solved it by getting X isolated. So the first one is a statement, so that was, we don't need to write a property there. That's just, actually what I can write down is given. That was already given. Now, what did I do between here and here? Well, it looks like I subtracted 3 from both sides, 3x from both sides, right? Because what I got was 2x minus 18 is equal to, and that would have canceled out. So this would be the subtraction property of equality. Okay, I'm just going to abbreviate it here. Now, between here and here, what I did was I added 18 to both sides. Okay, so when I did that, I got 2x is equal to 20, so that's the addition property of equality here. Now, between this line and this line, I divided by 2, okay? So that's going to be the division property of equality right there. Okay, so I've identified all the properties that were used to solve the equation below. Okay, let's try our hand at another example here. So we have the statement on the left-hand side, and we're going to write the property on the right-hand side. Now, the properties of equality are properties that we use to do things to both sides of the equation. So the first step here, by the way, the first step is the given. Okay, so we're given this equation. Now, between the first and second steps, the right-hand side remains the same. So nothing has been done to the right-hand side, but the left-hand side has been distributed. Now, it's not been distributed to both sides, so here, this we just say that the left-hand side has been simplified. So that's not a property of equality, necessarily. It is a distributive property of addition over multiplication, so it is a property of real numbers, but it's not. Properties of equality are the ones that, that allow us to use things that are, if A is equal to B, then what else is equal to the equation? Okay. So in other words, it's things that we add and subtract from both sides or multiply and divide from both sides. Those are the properties of equality. Now from here to here, all we've done is we've taken -8 and added it to 11. So again, this is just a simplify step. We haven't done anything to the right-hand side here. So the next one shows that -3 is being subtracted from both sides here. That's the thing that's changed here. So in this case, we are going to say that this is equal to, this is the subtraction property of equality. Now here, all we've done is we've subtracted 3 to get 6x on the left-hand side. We subtracted 3 to get -30 on the right-hand side. This is simplify. Okay. In the next step, though, we do have something different where the x is being subtracted from both sides. Okay, that's to get rid of the x, this x right here. So, oops. So this is going to be the subtraction property of equality because we're subtracting things on the same side, or on both sides. We're subtracting the same thing on both sides. Here, we're just simplifying because it's 6x minus x is 5x and so on. Okay, now to get rid of the 5x, we're going to divide it by both sides. So this next one is the division, this is the D, division property of equality. Okay, because what we've done here is that we have we've divided by 5 each time. And finally, all you're doing in the last step is you're simplifying it to get what x is equal to. Okay, and so that's how you would use the properties of equality to identify the steps that were used in solving equations. So properties of equalities are used in solving equations because we're doing the same thing. They're properties that allow us to do the same thing on one side of the equation as the other. If two things were already equal, then there's a bunch of things that we can do. We can add the same thing to both sides, subtract the same thing from both sides, multiply the sides by the same thing, or divide the sides by the same thing. Okay? We can substitute. Reflexive, symmetric, and transitive properties are also important. All right, and that's the end of the lesson for today.